You can also use stoichiometry and gases to make things happen. Now, stoichiometry is just the relative amounts of things. So one reaction we looked at in Chapter 7, Part 2, was hydrogen peroxide breaking down to water and oxygen, and it's a 2 to 2 to 1 ratio. So let's say that we're going to decompose 1.1 grams of hydrogen peroxide in a flask, and it's got a volume of 2.50 liters in the flask. The question is, what's the pressure of the O2 and of the water? Now, hydrogen peroxide is a liquid by default, and you can see it's an L right there. But the water and the oxygen are both gases. So we're going to take the moles of H2O2 and relate them to the moles of water and O2 in order to find those pressures. You wouldn't normally find a pressure of a liquid, but you can definitely find the pressure of gases. This particular reaction is used by this bombardier beetle, I guess. Anyway, apparently it sprays its enemies and stuff. It's a hydrogen peroxide decomposition. You end up with a lot of gas that creates the pressure that shoots out then this stuff on it. So, woohoo, biology is cool. So in this problem, we're going to take the grams of reactant and figure out the pressure of our products. And again, you could find the pressure of the water first or the pressure of the oxygen first. It doesn't really matter. I'm going to solve for the pressure of oxygen first. You don't have to, but that's what I'll do here, and I'll show you how this works. So grams of reactant into moles. Hydrogen peroxide is about 34 grams per mole, so that's 0.032 moles H2O2. Then I'm going to turn moles of H2O2 into moles of oxygen. Again, you don't have to do oxygen first, but that's what I'm going to do. 2 moles of hydrogen peroxide are needed for every 1 mole of oxygen produced. And again, that came from the 2 by the H2O2, and there's an invisible 1 right there by the O2. So that's where this ratio came from. It's a 2 to 1 ratio. So 0.032 moles of H2O2 should be creating 0.016 moles of O2. And in this problem, we want the pressure of the oxygen. So P equals nRT over V. N in this case is going to be the moles of our gas, 0.016. R, 0.082057 liters atmospheres per mole Kelvin. Temperature in Kelvin, 298 Kelvin, don't use Celsius, and the flask is 2.50 liters. So when you figure out the pressure then, pressure 0.16 atmospheres. So that's the pressure released when this much hydrogen peroxide decomposes. For the pressure of the water, you could do the same process we just did. You'd go grams of hydrogen peroxide to moles hydrogen peroxide. You'd use a 2 to 2 ratio to turn moles of hydrogen peroxide into moles of water. And then you'd use P equals nRT over V. And that would be fantastic. However, pressure is proportional to the moles. This is one of the gas laws we saw earlier. And in this case then, because we have a 2 mole H2O to 1 mole O2 ratio, it's 2 to 1. So if the pressure of the O2 was 0.16 atmospheres and we have twice as many waters, we can also just multiply our previous answer by 2. So 0.32 atmospheres will be the pressure of the water. And I encourage you to go back and check that out if you don't believe me. It's quite all right. The proportional sign is that little kind of symbol right there. It's kind of weird looking, but that's what means proportional. So that means as one goes up, the other one goes up. All right. And pressure is proportional to the moles of this process. And we have twice as many moles of water as we do oxygen. That's from the 2 to the invisible 1 right there again, 2 to 1. So the pressure will be twice as big, 0.32 atmospheres. The total pressure in this system will be the pressure of the water plus the pressure of the oxygen. So if you add up our last two answers, 0.32 for the water and 0.16 atmospheres for the O2, the total pressure, 0.48 atmospheres in this system. So this is how Dalton's law can really help out. And you can also see then how stoichiometry is really important. We're going to use those balance equations in so many ways. In this case, we used it to go from grams of a reactant to essentially moles and then pressure of products. Kind of cool.